Hello everyone, this is Ruby. Today we're going to talk about measuring variability and in particular measuring the range. Variability can be measured with the range. The range is the total distance covered by the distribution from the smallest score to the largest score in the distribution. The range is important because it tells us how spread out the scores are. So for example, if we were to look at adult heights, which is shown in distribution A, we would see that they are relatively close together. Adult heights range from 58 inches to 82 inches. As you look at the distribution, you see that it is narrow, and that shows that all the scores are clustered tightly together around the mean. And sure enough, the range for distribution A is 25. If we were to look at distribution B, what we see is it looks quite different from distribution A. You see that the scores are quite far apart, that the distribution ranges from 110 to 230. So if we were to do the math, we would see that the distribution here, the range is 121. So that's quite a bit larger than 25. You also notice the shape, that the curve is quite wide, whereas for a distribution A, the curve was quite narrow. Hence, when we ask the question, which distribution has the greatest spread, the correct answer would be distribution B. Now, when we go to the next slide, what we see is that if we were to complete a sample problem with the numbers of 5, 7, 10, 11, and 20, if you look at the number line that I've drawn for you, you see that we have an arrow at 5, 7, 10, 11, and 20, and you see that we have a simple curve that covers those. If you were to count the number of scores that you have there, you would see that you have 16 scores. And those 16 scores would represent the range. Now we're going to go ahead and see how we can do that mathematically. So to do that mathematically, what we would do is we would compute the range. And what we have here is our sample problem with the following set of numbers, 5, 7, 10, 11, and 20. The first step would be to find the lower real limit for the lowest value. The lowest value is 5, so the lowest real limit is 4.5. The second step would be to find the upper real limit for the highest value. The highest value is 20, so the highest real value would be 20.5. Now, for step 3, what we're going to do is we're going to use the equation where we take the upper real limit for the maximum value and subtract it from the lower real limit for the minimum value. So essentially what we have here is our upper real limit, which was 20.5, and we're going to subtract that from our lower real limit, which is 4.5, and our answer is 16. Now there is also a shortcut method that I will show you next. For the shortcut method, what we're going to do is we're going to find the highest score of the distribution, which is 20. Then we're going to find the lowest score in the distribution, which is 5. And then we're going to subtract the highest score in the distribution from the lowest score in the distribution. And we have 20 minus 5, which equals 15. And we're going to add 1 to the result of step 3 because we want to account for the upper and lower real limits. So then we have 15 plus 1. So remember that accounts for the upper and lower real limits, and we get 16, which is our final answer. So that is the range.